everyone, welcome back to our channel. This is Dr. Nazma and today we are going to discuss the previous year questions of chemical bonding. Well, this chemical bonding is a chapter that falls into class 11. If there is somebody who is in class 11, even you can watch this video. Well, this is especially for JEE mains, not for NEET or mains, not for NEET or advanced. If there is somebody who is preparing for those competitives and you want the previous year questions of your competitive exam also, without hesitation, let me know in the comment section. I'll help you with that. Cool. Let's get started. And as usual, if you want to get most benefited out of these lectures, what you have to do? You have to be having a running notes and you have to practice the things along with me. Only then you're going to learn. So this is the first question of the class today. The question have been asked in 2013 JEE mains paper. And the question is the stability of the species Li2 minus and Li2 plus in increasing order is. So they have given three species as you already see on the screen, and you have to arrange them in the increasing order of stability. Fine. So how do you deal with this question? You can pause the video and you can give it your try. Always remember, you studying the concept is something, but you being able to apply the concept to solve the question is what determines your rank or score in the exam. Fine. So how do you deal with this question? Have you paused the video and tried it? If you have got it done, then that's fine. But then in case you were stuck, listen to this. No need to get disappointed. Whenever you want to compare stability of the molecules, that with respect to the chapter chemical bonding, the first thing that you need to look around is for bond order. So bond order, what's bond order basically? This is nothing but the average number of bonds present in between any two atoms of the molecule. So more is the number of bonds, more is the bond strength, or maybe it determines various other factors like bond angle, bond length, bond strength, etc. etc. So now let's understand the relation between stability and bond order. Fine. So bond order and stability, both of them are directly proportional to each other. Means what? Means more is the bond order, more is the stability. So now first what do we need to do? We need to find out the bond order of the given molecules. Fine, but then how to find the bond order? I already have taught you the shortcuts to calculate the bond order, but then if you have not watched the video, you would have to watch it. It's there in the playlist. Go watch it. It's only a 5-minute video. I gave you 4 formulae to be able to do it. Fine. So for Li2, using those shortcut formulae, the bond order of Li2 is equal to 1 and bond order of Li2 minus is equal to 0.5 and bond order of Li2 plus is also 0.5. I'm again telling you, to calculate bond order, I have given a shortcut in another video. Please do watch it before you could continue, or maybe after this video. Fine. So what is the relation between bond order and stability? Just now we discussed both of them are directly proportional to each other. If both of them are directly proportional to each other, higher is the bond order, higher is the stability. So lithium 2 is having highest bond order. So lithium 2 is the one which is having highest stability. Then what about the rest? Both of them are having 0.5 each. Now out of these two, which is more stable? How do we know? When the bond order is same, to identify the stability, you need to look at the number of bonding and anti-bonding electrons. If you are having more number of anti-bonding electrons, the stability will be lesser. Why? Because they are anti-bonding, their energy will be higher. Higher is the energy, lower will be stability. And now how do you know out of Li2 minus and Li2 plus if you are having more number of anti-bonding electrons in one of them or not? For that you just need to observe their electronic configuration. And when you observe electronic configuration, Li2 plus will be having less number of anti-bonding electrons, which means Li2 plus is something which is secondly stable. Li2 plus, and now obviously Li2 minus is left. So this is the order of stability. I repeat, to calculate bond order you need a formula. The usual formula that you use is Nb minus Na by 2, but then that takes long time if you want to apply it. So use the shortcuts that I have taught you in one other video. And on other hand, another thing that you need to remember is when bond order is same to same, you need to observe the count of bonding anti-bonding electrons. In Li2 plus, totally there will be how many? 5 electrons only. When you write their configuration, it will be sigma 1s2, sigma star 1s2. 4 electrons are already over. The other one will be sigma 2s1. Correct? And now, when you look at the configuration of Li2 minus, 6 plus 1, 7 electrons it has. Correct? One minus charge is there, right? So one extra electron, and that means it will have a configuration of sigma 1s2, sigma star 1s2, sigma 2s2, that means 6 electrons are over, and sigma star 2s1, which means it has 2 plus 1, totally 3 antibonding electrons, whereas Li2 plus has only only 2 antibonding electrons here. Done? More number of antibonding electrons, less is the stability. Cool everyone? Did you all understand this? Now let's move on towards the second question. Let's take one other question which have been asked in the year 2013 itself, 2013 JEE. And the question is, there are 4 options and you have to identify one such option in which the molecules do not exist. Like for example, say option number 1 is H2 plus and He2 minus 2. Option number 2 is H2 minus and He2 minus 2. Option number 3 is H2 2 plus and He2. Option number 4 is H2 minus He2 2 plus. So I gave you 4 options. Identify one such option in which the molecules written do not exist. So you have to find the molecules which do not exist. But then what does it mean? Like molecule doesn't exist mean what? The molecule doesn't exist mean its bond order is equal to 0. So again, this is also a bond order related question, and both of these questions were asked in 2013 only. Did you see the last question and this question? So find the option, find the right option. Find bond order for them right now and see whose bond order is equal to 0, and thereby find out which molecules does not exist. And again I'm telling you, bond order बहुत ही important चीज होती है. You must be able to calculate bond order in 30 seconds, and I gave you already shortcut formula in one other video. Yeah, so as per those shortcut formula, when you calculate bond order, H2 plus का bond order क्या होगा? Okay, you calculate it. Pause the video and calculate it. Fine. So calculate it and decide the answer. And now if you have paused it and if you already have tried it, let me explain you the answer. So in all these cases, when you look for bond order, the 0 bond order can only be found in case of option 3. Why? Because observe how many electrons do you have in hydrogen? 0 electrons. H2 has 2 electrons, but then it also has plus 2 charge. Means already it has 0 electrons. When 0 electrons are there, you can't further talk about bond order calculations and all of that, right? Because what is bond order? Bond order is nothing but number of bonding and number of anti-bonding electrons difference divided by 2. When this is 0, everything becomes 0, right? So bond order of H2 plus 2 is 0. What about He2? He2, 4 electrons it has. 2 of them are bonding, 2 of them are anti-bonding, divided by 2, altogether 0 again. So bond order of these two species is equal to 0. So these do not exist. Right answer here will be option 3. Now let's move on to the next question, which have been asked in again 2013, but then this is not related to bond order directly. The question is like this: which one of the following molecules is expected to exhibit diamagnetic behavior? Okay, I'll give you the options. One is C2, other one is N2, next one is O2, last one is S2. You have to find the one which has a diamagnetic behavior. Diamagnetic behavior. Okay, so you tell me, how do you detect if something has a diamagnetic behavior or not? You have to look for if that something is having paired electrons or unpaired electrons. So based on pairing of electrons, you can determine. If your molecule is having any unpaired electrons, it would behave paramagnetic. Paramagnetic means it has unpaired electrons. At least one unpaired electron is enough. Diamagnetic means no unpaired electrons. Means all the electrons are paired only. Now observe C2, N2, O2, S2. In which case do you have paired or unpaired electrons? And now if you ask me, ma'am, how do we know this? If you really want to be accurate about this kids, you just need to be able to write the configuration quickly. There are some shortcuts around this also, but I really don't want you to know that, because those shortcuts have numerous exceptions. Like, you will get confused in exceptions. The shortcut is of no great use. So let us observe how many electrons are there in each case. Carbon has totally 12 electrons, nitrogen has 14 electrons, oxygen 16 electrons, and S2, tell me how many electrons are there in S2? 32 electrons are there, correct? So which do you think? And also this is a multiple correct answer question, multiple correct answer question. Okay, now tell me, how do you see it? You just need to write the configuration. Start from the simple one. Carbon is the one which is having less number of electrons, which is 12 electrons. So what is the trend to write configuration? Sigma 1 is to sigma star 1 is to. And then is sigma 2 is to sigma star 2 is to. How many electrons did we exhaust? 8 electrons, done already. And the next one will be pi, isn't it? Sorry. The p orbitals which involve in pi bonding, correct? So how do we start writing the pi bonding? After 2s2, after sigma star 2s2, it will be pi bonds, and it will be pi 2p. There will be 4 bonding electrons. So after this, there are no electrons to be filled in pi star. So now observe, in total how many electrons do you have? You have all paid electrons, in total 12, but then all of them are paid electrons. So since all of them are paid electrons, it is something which is diamagnetic by nature. So C2 is diamagnetic. In the very same way, you have to write the configurations for N2, O2 and S2 also. And when you write the configurations for them, you have to observe which one is having unpaid electrons. If unpaid electrons, then it is something which has paramagnetic behavior. So here C2 is having all the paid electrons, and hence this is diamagnetic. And very similarly, when you observe electronic configuration of remaining options also, you will get to see that N2 is also something which has all paid electrons. So both C2 and N2 are diamagnetic by nature. But when it comes to oxygen and sulfur, they are not diamagnetic because they contain unpaid electrons in their molecular orbital electronic configuration. So what did you understand from this? You observe the questions of 2013. In 2013, there are 3 questions asked from chemical bonding. Fine. So first one is about bond order, related to bond order. Second one is also related to bond order. And third one is related to magnetic behavior. All 3 questions are from molecular orbital theory only. So out of entire chemical bonding, molecular orbital theory is very vast, and you have more scope of getting questions from there. Focus on them, and I'm telling you, there are so many shortcuts. You really don't need to work extremely hard for chemical bonding. Many techniques are there, and I have kept them uploaded in a playlist already. Please go watch them and learn the questions easily. So in the next lecture, in the next video, I'll come up with more questions of chemical bonding which have been asked in the year 2014, 15, 16, 17, 18 and 19. Okay. So until then, you keep working hard. I'll see you in another video. Bye everyone.